Hello, and welcome to the SaturdayMP Show, episode number 39, being recorded mostly live on April 1st, 2024. This is a show where we answer questions about shipping secure, high-quality software faster. And today we're going to, today's going to be kind of a fun day, because we're kind of having a back and forth a bit with a person named Ndidi about the human resource machine game. And how we've both actually been struggling with the three-sort problem. That's a Fibonacci one. But we struggle with three-sort, and Ndidi has posted a way to beat the number of cycles. So we're going to try that one. But as far as I know, Ndidi has not, and myself have not figured out how to beat it for the number of steps. So let's see if we can do that today. I guess before we get too further, I'm your host, Chris. And if you do have any questions you want answered, you can send an email to ask@SaturdayMP.com. That's ask@SaturdayMP.com. So you just send emails there. Or just leave them down below in the comments. So like Ndidi has in the past, and a couple other people have. So this is Ndidi's human resource machine here. So yeah, that's what we're going to try today. So let's, I'm going to pause the video here for a second. And while I get human resource machine set up, and then we'll try Ndidi. Well, spoiler, I already tried Ndidi's program and it does work, but we'll kind of go through it real quick, I think, and then we're going to try and solve the other optimization challenge, the speed challenge. So, or sorry, which one did Ndidi solve here? Number of cycles. So I think Ndidi solved the size, and then we'll try solve the speed for the three-sort problem, which I haven't done either of them yet. So. Or I haven't gotten any of those challenges solved, so let's see what happens. Hold on, I'll pause this here. Alright, we're back here. There's the human resource machine. Let's see if I can get set up here. Alright, there's the three-sort problem. So I haven't played much because I've been kind of just wanting to solve this particular problem. So for those who don't know, you can watch some of the previous videos again. Before me. So what's the problem here? You need to sort the set of numbers. And so here's this is basically, we want to sort them in order. And for those who don't know it, the human resource machine game is kind of acting like you're simulating like assembly program. You have very limited instruction set, and you're basically almost like moving data from one register to another from memory and stuff like that. So as data flows in, we only have like say 10 registers down below here, and we have to move values around, and these are the only instructions we have are the ones on the left here. So we can take things from the inbox, which is here, that's our input, and then our output's here. We can copy from one thing to another. We can add or subtract numbers. We can bump, which means add or subtract one number, and then we got jump commands. So this first three-sort problem here, this is me just basically solving it. This third one here, this is Ndidi's problem, or solution. So if you remember you can actually cut and paste your solution. That was what that text was. So if you copy it and then paste it, it'll give you that kind of text format that you saw in the YouTube comments there. And this middle one, this will be the one where we actually try and do the last challenge. This is probably me trying stuff before. So I'll just show people, if you haven't played it before, like this one will basically solve the problem. So it just basically goes through your little program here on the side, doing each step in order, and you can watch the little fellow there move stuff around. And so my typical way for solving these problems is the first tab is usually just me solving it, and the second tab is usually me optimizing it for one of the two, for either the size or the speed, and the third one is the other one. But this one, this problem has been a year, or this problem I haven't been able to optimize. All the other ones I've been able to figure out, so, and then we could speed it up here, so make this go a little faster. There, something like that. So there's no, for those that are used to programming, there's no functions or anything like that. You just have these jump commands and a lot of these copy commands. So, there. hopefully, I think I ran this once this morning, so this should work and just solve it, but it won't beat any of the challenges. So there we go. Yeah. So we did this. So we solved it, but we didn't get the size challenge or the speed challenge with this one. But now if we go try, this is in Didi's problem here. We got a bunch of jumps right to the beginning. So we're gonna try and figure out what their program does. Because mine was okay. So I grabbed the 3 things from the inbox. That's kind of my initialization. My initialization was always grab the 3, put them into memory or into registers, however you want to say that. And then I think I just did like a bubble sort. I would just compare, because there's no like loops or anything. Like I just did a bubble sort. Like there's no way to say like treat this as an array, which makes it hard. So I just treat it like a bubble sort, I think, and we'll just sort them all out, and then finally the output. So, right, what was this? So let's just run it here. Oh, I guess too we could do these steps one at a time. So, okay, so that's my initialization, and then I needed to remember the. Oh, okay. Basically, then I compare these two because I want the lowest on the left. Is that what I did? No, I put the highest on the left apparently. Oh no, I put the lowest on the left. Okay. Yeah, and then I would just kind of compare it again. And then compare these two. And get the lowest on the left. But again, I have to go back and compare this initial 2 here. Right, because the 3 is less than 5, so I have to move 3 over there. Okay. And then now we're sorted. We're done. Yeah, we just checked them all. Everything's sorted, so we can put 3 and then 5 and then 8. And then we'll reset and do it again. Okay. So let's see. Didi, let's just run it. Well, I ran it before and it solved. Well, again, I can't remember which challenge it solved. But oh, they're not even using the extra memory like I was. Oh, good job. Yeah, I was using an extra register. I'm not even using that. All right. Okay, so the speed challenge. So they did it in 78 or fewer steps. Oh, that's awesome. Okay, but this took a lot. Huge amount of more steps. 34. 60 commands instead of 34. Wow, really? I guess this is a really long program. Holy jeez, yeah. Okay. Oh, because basically it looks like Indeed he wrote out all the different comparisons you could possibly have to do. Okay, let's step through it. Let's see what happens. Okay, so I think it looks like, yeah, basically it looks like the first part's just the initialization. Well, let's jump. Oh, speed it up. So we just set it up. Alright, and then right off the bat, we're subtracting 1. So we did 0, 1, 2. Oh, okay, so we're comparing like register 1 or memory spot 1 to 2. And we're going to see what if it's negative. Okay, if it was a negative, we would keep going. So negative means that 3 is smaller than 2. So then we do a huge, where's that jump? Oh, I reset the thing. Whoops. Jump all the way down there. 1 is greater than 2. Okay, so if it was a negative, then we'd swap them. Okay. So, sorry, let's do this again. Alright, so we'll compare 2 to 4. It is negative, so 2 is less than 4. So then what do? We want to take 4. We subtract 0. It's negative, so 4 is less than 7. Oh, I think I see what it did. Right, and now we're just going to spit these out in this order. Oh, okay. It's got the two. Right. Oh, so you already... Oh, that's interesting. DD already checks, like, is it already sorted left to right or right to left? And if it is, then... Oh, okay. Interesting. Okay, so this is a reset. Now we're saying is 9 less than 5? It's not. Is 5... Oh, okay. Yeah, this one's already... This is sorted, but in reverse order, so it's just going to spit it out. Oh, okay. Wow, that's pretty cool. So you're checking if these three are sorted in either order, and the next one's going to probably be a little harder. Oh, really interesting. That's why I love it when people submit answers or solutions or something, because it's stuff I would have never... I don't think I would have ever thought of this. That's a lot. It really hurts my brain as a software developer, too, to not have access to loops and, like, functions and stuff. And you kind of make functions with these jumps, but... Or not having an array. This is the one that really hurts my brain for this. Okay, so but this is 9 and 2. Okay, so 9 is not, or 9 and 7. Now, this one's, oh, this is in the correct order too. It's just gonna spit it out. Oh, that's hilarious. Is there one where... Oh, is there one? That's awesome. There's nothing in the inbox. It's done. Okay, we gotta try that again, because... No, go back. Because it's either sorted... There's gotta be one where it's not sorted one way or the other. Or are they always sorted one way or the other? 359 minus 37. Oh, maybe they are. Oh, okay. If we make that assumption, can we make our... Do they tell us that in the instructions? Right, because what would happen if you had like 7 and 9 reversed? Oh, I wonder if that's... Huh. All these are always sorted one way or the other. Huh, I never noticed that before. Do they tell us that? Three, 5, 9. 7, 4, 2, 3, 5, 9. Give me an example. 7, 5, 1, 2, 5, 7, 3, 8. See, this 3, 8, this is one that doesn't come up. Indeed, at least it hasn't. But indeed, it has a bunch of solutions I think would solve for that. Try one more. So this is sorted already. So the algorithm figures that out. Three, 7, 9, 3. Yeah, like they're always... Oh! That's really interesting. Okay, maybe we can cheat a little bit to get this optimization problem down. Because... Huh. Okay, so 1's less than 2, right? Okay, so indeed he does have logic in there, like... If the middle one is weird. I still don't see it again. It's like 7, 4, 2. Huh, okay. Okay, but indeed's solution is basically... Let's have... Set everything up. And then try to figure out if it's in... Already sorted, either left from right, right to left. That's what these two do. And if it's not, adjust it, and then... Okay, if it's not, you're going to go here. Oh, but you're throwing it in the outbox already. Oh, yeah, because my solution was always to put the smallest one in the left, no matter what, and then kind of bubble sort it, and that's why it took so many steps. Like, how close were we with this one? Like, we're one command away. Oh, interesting. Yeah, I wonder if Indeedy's would work if you had a number in the middle. Huh. But this problem just never seems to come up. Okay, so let's go here. This is me. Let's just clear. Right. Do I wonder if I just assume it's going to be sorted either one way or the other. Because I guess, okay, so there's only 3 numbers, so I guess worst case. Worst case, you're always just going to be one off, right? Like, is that correct? Like, we only ever have to move one. So, all right, let's go. Let's do some examples. So, if this is 4, this is 2, this is 3. Okay, so if we end up with something like this, what does Indeedy's do? Okay, so if we ended up with something like this, right, boom, 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 we compare 2 and 3. We know that 2 is smaller than 3. But then we have to compare 2 and 4. Oh, okay, but in this case, we know that if 2 is smaller than 4, then we know 2 is the smallest. No matter what. Oh, or we know it's the biggest. Or sorry, 3 and 2. Maybe I can get away with this. Okay, so we always want to do the inbox, yeah, so inbox, 2, 1, yep, inbox, 2, 2, inbox, 2, 3. Okay, so if we have these numbers, 4, 2, and 3 come in, we compare 3 to 2. Oh, but if we move 2 there, then we're good. Okay, so we compare, so we subtract with 2, because we have 3 in our hand still. So we know that 2 is the smallest. Oh, we know that 2 is smaller than 3. So I don't know. Okay, so if there's negative, massive jump. And what did, oh yeah, mine I went all the way back to 0. It's kind of a waste of a step there. So okay, so subtract those 2. 3 1 is less than 2... Yeah, if that's the case, you're done. Boom. Write it out. I guess the one thing, this reason this has such a huge size is because you do the write out multiple, like at least twice. Oh, like 3 times, depending on the order there. Okay. So that's going to increase the size a lot. So those two. In this case, I could put 2 there. Do I want them smallest to largest or largest to smallest? The smallest to largest. Okay, so we compare 2 and 3. So we know 2 is smaller. And then we can compare 2 and 4. Okay, so let's just... Yeah, so that's okay. So it's a negative. So it's negative. Jump somewhere. If it's not negative, then just leave it. Then we know that this one's small. Then we okay. So let's. So if it's negative, then we know the 2 is smaller than 3. If it's not negative, we know space 3 is smaller than 2. I should really change these. Okay, let's it's getting confusing. Let's put this as 9. And we'll put this one as 7. And then so okay, if it is negative, then we're going to compare this one to this one. Oh no, but I have to add that again. Oh no, wait. I could. Can I cheat? Can I go add 1? And then if that is negative, then we know that this one's the smallest. Outbox. Yeah, in this case we would just outbox. Oh, no, it's not gonna work. What was... Maybe this is what I did last time. So, this one's less than this one. Swap them. Oh, but indeed he didn't even use the extra memory. Because that extra memory step, that's a lot of extra steps to move something there and then copy it over there. Just assume they're always sorted in one way or another. I bet you if I... Because the other thing is sometimes you try a solution, they'll give you extra data that'll mess with it. They'll be like, oh, you just solved the data we gave you, but... here's some extra data because you didn't fully solve the algorithm. Okay, so... these two are negative. Let's just see. Well, we don't have any of those. Okay, so 7, 4, 2. So if we compare 7 to 4, 7's big. Compare 4 to 2. 4 is 2 is the smallest. Now, is there some fancy math where I could just add this number to this guy and see -2? If I add these two, so if 7, if this was like 1, I added them, it would still be negative, but this is positive. So that means, does that mean that this one's the biggest number? Or this the smallest number? Let's see. Okay, so if they're negative, add to 1, and then okay, that one's negative. We have to do something. But if it's not negative, then we can just write them out. Okay, let's see if that'll work for that first set. Yeah, okay, so that worked. Oh, let's get to that second. Oh, we need another jump here. Let's go back to initialization here. Oh, in that case, I would need to do something. So it's not negative. So I can compare it to this with a subtraction, maybe. Okay, subtract 1. All right, let's see. So, yeah, we had to figure out. Maybe Indeed was on the right path, but actually, I don't know. It's probably going to complain. Let's see. But we only care if, like, sorted one way or the other. We don't. They're not going to mix them up. Oh no, I did that wrong. What did I do wrong? Oops. Let's try this again. Oops, I screwed something up here. if it's 0, yeah, add. It's negative. Oh, let's go here. 2, yeah. All right, that's better. Now let's try the second way. It's not negative. Okay, so this one's so I have to. I guess if we're just even cheating, like we're assuming they're sorted in one way or another, we don't even need to check the middle one. We just need to check the first one. I bet you it's going to complain. Okay. So let's see. If jump if negative, we want to. It's not negative. I don't know what to do in that case, I guess. This one is up here. And then jump down here. Let's see if we got it. Okay. 3, 2, 1. Done. Alright. Set up. Oh, I got an extra step in here. So subtract 2. If it's 0, jump to here. Subtract 1. Oh, yeah, no. If it's not negative. Okay. Is that right? Okay, we didn't screw that up, so that's good. It's not negative, so we'll go here. Oh, see, they are messing with me. Negative 2, 3, yeah. Yeah, okay, okay. Finally. Let's put this up. Let's get to one of those messed up. They actually did put a messed up one in there. Okay. This one's fine. This one we can handle. This was a tricky one. Okay. Okay, so now we need to figure out what was how many steps? 27. Ooh. I think we're getting pretty close. Okay. Okay, so that. Okay, so we know the one, like we know this guy should be outputted. Like this is clearly the smallest number, is 3. We just need to figure out 7 and 8 here. Okay, so it's still negative. Do I just compare, like, boom, boom, boom? This is the smallest outputted. Only got a couple jumps or a couple steps left. So what's the best way to do this? And then I need to compare 7 and 8. So should I output 3 right now? Well, that's an interesting way to do it. Like we just compare. If it's not smaller than both, it'd be nice to. Okay, let's take a look. What did Indeedy do? Oh, stop it. Okay. Oh, okay, yeah. So Indeedy did just kind of output as found. This is negative. But this is okay. So this is the weird situation, right? We didn't get one or the other. Yes, this is sorted one way, no problem. Yeah, it's either going to be sorted one way or the other, or that middle one's going to be messed up, and then we just have to figure out if we put it on the left or the right. Okay, done. Okay. That is fine. Okay. It's not negative, so what we need to do is we need to move these two. And then jump, I think. Okay, so was a negative. Outbox that, and then we could jump. Even jump here. No. We want a few steps. So I hate using an extra piece of memory because it always screws everything up. Right, yes. This either has to be moved to the left or to the right. Yeah, okay, so that's really what we have to do. We have to figure out, do we take this one in the middle, and do we move it to the left, or do we move it to the right? I wonder if that would work. So, we're at to 0, 3... Okay, so I'm going to clear this. Yes, it's fine. Alright. And then, inbox, copy to there. Let's get rid of these numbers. We don't really need them. Okay. One. Excuse me. Okay. So now, what we really need to do is compare is two. Right, does this guy in the middle need to move to the left or to the right? That's really all we need to know. How do we do that? We take because in this case we'd want to move it to the right, but 7 is less than both of these two. How do we know which one is less than? Okay, we could compare 8 to 9, and we know 9's bigger than 8. So then if we compare 7 to 8, we know it has to go to the right if it's smaller. Oh, okay, we can try that. So let's compare, let's subtract from 0. Okay, if this is, if negative, okay, maybe I'll put a little blah 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 in here. Here. Okay, so it's 0. This is wait, is that gonna work though? Like 2, 5, 9. It's gotta be less than both of them is the problem, or greater than both of them. Okay, so but if we compare this and this, so if we get 2 and 9, okay, we know that 2 is the smaller number. It would be 9, 5, 2. So 2 would be the smaller number. Oh yeah, then if 5 is less than 2, yeah, okay. I think that's going to work. So, okay, so if it, okay, so in this case, let's do one more step. Negative. So we know that 2 is the smaller number here. So we can move. Well, in this case, we don't have to move anything, but when we compare 5, so 2 is the smaller of these two, and then we compare 5. If 5 is smaller, it's bigger than 2, did you do anything? Okay, so we could jump here, and then we could. So it's negative, so it's going to take us here, which is 3. Oops. 3. 2 is less than. And then we can add to 1. And then we can check if that is negative. Okay, so if that one's negative, which it is, so that means it's sorted left to right in this particular case. If my logic is correct. So we don't need to move anything. And we know that this is the smallest one. So then we can just output. Alright, we can just outbox. Oops. 1, 2. So that, we know that would work, and then we go back up and we do it. So that'll solve that first one. Okay, so it's not negative, so we know that 7 is bigger than 2. So in that case, we want to subtract. Okay, so in this case, this is 2 is greater than 0. And then in that case, we want to subtract from this one. Okay, and oops. Okay, so figure that 2 is greater than 0. So subtract that guy. The smallest is on the left. We're all good. We can just do this, but in reverse. Okay, so we could go oh, how many steps are we up to? 24. Okay, and then we need to jump. Okay, so that'll work for 2 sorted. Oh, no, oh, I screwed some up already. A little faster. There we go. Jump if negative. Oh, there's a problem. This needs to go this. Oh. This one will work. Yeah. Okay, so this is the one where you have to do a swap. Okay. Oh, we get this, jump it. So this is where if it's negative, then we need to do a swap. Quick, boom, boom, boom. Here's a good one. Okay. So we know this one is less than this one. Okay. So we added one. So that was positive. So we, in this case, because it's positive, we need to swap the 7 with 5. Okay. So let's remember that step 18. Oops, jump with negative. But it wasn't, so we need to how many? What's the challenge? Maybe 5 commands. Ugh. Oh, maybe we could do it. Okay. If it's negative, we're gonna 1, 2, 3, 4, 6 and 6. Oh, that's gonna be too many. It's 12. I don't think that's the answer either. Okay. So 8. We want to put 7 and then 8 and 9. I'm just kind of coming with the same solution in DD, but DD, how many steps is in DD? A lot. No, like 60. How can we get... copy from 0? Okay, so let's say so we got here, subtract that one. If it's not negative, we know. Can we do a copy from Outbox? Can we just have these written out once with some fancy jumps in between? When you outbox it, you lose it though, so it's kind of a shame. How many steps does it take to? 1, 2, 3. Right, you have to copy 0 to 5, 1 to 0, 5, 1, 2, 3, 4, 5. It's like 6 steps. Ugh, so gross. Okay, so once I took 8, I grabbed 4. Compare them. Okay. Maybe this will be another failure video. Let's try again here. So, took inbox. 0. Grab the next one from the inbox. And subtract from 0. Oops. Okay, so -4. So that one's smaller. Yeah. Okay, so 6 is smaller, so let's write 6 down here. Add 0. Copy to 5. It's not. Get to 6. Okay. Add 0. Copy to 6. Alright, let me grab the next one from the inbox. Let's see. Let's actually write this one. Oh, maybe. Let's write to 2. So we write to 2, and then we 3 add to 2. Add 2. If it's negative, write it to 1. Positive, write it to 3. So subtract 2. If it's not negative, just write it to 3. And then we're done. And then we output it. And then we do this. 1. 2. 3. And of course, I jump to go back. Oops, I forgot to add again. Get the first one, compare it to we put the left or right of that. The second one, compare it to we put the left or right of that one. Because these two have sorted. It's just this last one. Where does it go? Right? Okay, so I guess there's 3 possibilities. One, it can go just bigger, goes to the right. Did I put it to the left? one's negative, so I... This one's such a pain. Ah. Oh man, so okay. Okay, so that one's negative. So if this is negative, then we know. Well, we don't know it's the smallest per se. We just know it's smaller than that. So we could do our little trick where we add. So if it's negative, we can add it to this guy. And then, oh, I can't remember. This is 2. So we got -6. If that was 1, -7. Oh, it's negative or 0, then it's the smallest one. Oh, this could be a problem. Oh, yeah, okay, sorry. If it is... No. Okay, this is right. Okay, so this is negative. Then a box. Copy from 1. Outbox. Copy from 2. Outbox. And then we go back to whoops, I forgot to add there. Oops, subtract. Oh no, did I lose that? Oh, I've lost that number forever though. Right? Okay, let's maybe not do that. We'll have to. So we get it from the inbox, subtract, it's negative. Let's see. And then this is negative. We want to jump to here. Oh, Oh, how many steps is it? 22 already. We're better off before. Oh, I need to add first though. Add that back in there. One. Oh, this is worse, because now where do I put this? Oh, we got 9. Right, so it's not negative. Oh, it's so frustrating. This one is probably the one I'm close. Maybe I should just stick with this, because I'm pretty close. Copy. Okay, let's clear this. Paste. If we can get rid of one more. 34. Okay. That's what we should have done from the beginning. Let's see what this does. So set that up. And I go back to 0, which is kind of a waste because I'm already at 3. This is probably where I can get rid of something, right? If I just did it backwards. Jump with negative, jump with 0. I don't know why I have a jump with negative and jump with 0. Why do I have that? It's still gonna work. Oh, is that my solution all along? Oh, okay, okay. Okay. Does it fail now? Why did I have that 0? minus 3s I'll probably do. Okay, let's see what happens here. 8. So we know that's bigger. Oh, we get an infinite loop. Oh, that's why. Oh, that's hilarious. Okay, so that's why I have this jump boost 0 there. So I put these in a different order. Then we wouldn't even have this copy from 0. Can we do that? I might have to reverse the order with you. Probably need that. Oh, stuck in a infinite loop again. Okay, but we could put those two back, I think, if is that it? I just had to put that in that order. Ah! Okay, show me where it fails. Okay, there we go. Fail. It's always the last one. Why can't they put it the first one? Okay, what were those numbers again? Let's go back. Okay, 5, negative 4, 6. Not 0. So we definitely want 6 to move up. So 6 does that. That's fine. 0. 1. Oh, I need to. Oh no, 6 is there. Oh, I reversed the order, so I need to. Okay, so 0, subtract. Here. Oh, 34 is so close. Yeah, I reversed the order there, so I think I need to switch some of this. Nope, don't need to do anything. Nope, it's all in the right order, so we're all good. Try this one. Nope, it's not negative, not 0. So that means we get so 9 and 5. It's done. Oh, but when we come back here, oh, in this case we don't need this jump anymore, right? Oop, you can go away. I think. Okay, this is fine. Great. Swap those two. Great. Those two around. Now we have to go back all the way to the beginning. Oh, is that where we had that copy 0 in there? Because when I get to here, go back. Oh, before I jump here, I need to copy from 0. Okay. So let's do that. We gotta start the bubble sort again. Nothing to do. Put it here. Yeah, 6 there. This could be it. Oh, is that all I needed to do? I was so close last time. Here are these two. Correct order. Oh, is that it? Yeah, we did both. Oh, that's great. Well, thanks to Ndidi for doing the speed. Okay, let's end the video there. Thanks to Ndidi for doing the speed challenge. That was great. I'm glad I figured out the size challenge. So, actually, before we do that, let's do a quick compare. So, what did I do? I had 35 commands here. I just made sure that the first thing I loaded, so I got rid of this copy 0 here all the time. And then I got rid of I got rid of a couple jumps. So we basically initialize everything. Then we compare, subtract 0 from 1. Oh, excuse me. If they're negative, they're in their correct spot, so don't do anything. If they're not, then swap them. And then we compare 1 to 2. If they're in their correct spot, don't do anything. We're done. Output. If not, then swap them. And then we have to go all the way back to the beginning and then just kind of run through this algorithm over and over again until we've got it completely sorted. Okay. And then, yeah, the other thing is, we didn't want that copy 0 here. Well, I guess we could have put it there. I think we... Oh, what did we get rid of? Did we get rid of some jumps? Basically, we just have to initialize this again. What did we get rid of? Oh, we got rid of this. Was it that jump? Right. Oh, okay. We got rid of this jump. This is the big thing. It wasn't even that we moved that copy 0 from here to here. It's that we got rid of this jump because we don't We might as well keep sorting all the way to the end of the array if they're in order. There's no point, like, we would jump back here and then do that sort again, but these are already sorted, so it was kind of a waste. Oh, that was my problem, I think. Okay. Well, yeah. Well, cool. Well, thank you all, everyone, for watching. If you enjoyed watching me struggle through this for almost an hour and 20 minutes, hit the like or subscribe button or that, or especially if you like Indeedy's solution here. Hit the like or subscribe, or shoot Indeedy a message. They might like that. That was very great. This is a very inventive solution, I think, that just outputted all the different orders. That's super interesting. Like, it's all the different possible outputs. Yeah, that's pretty amazing. So it's a ton of steps, but it got what do they call it? I always get those wrong. It's steps. So there's a ton of commands, but it did it in very few steps, which is awesome. And so this is the one with a lot of commands, or very few commands, but a lot of steps, because we do a lot of repetition going over and over that again. Okay, but yeah, anyway, feel free to hit the like and subscribe button if you like this, and others can find out about it. Send Indeedy nice messages. And yeah, thank you all for watching, and I hope to see you next week. Take care.